Okay, Chapter 3, Lesson 6, Graphing Piecewise Defined Functions and Shifting and Reflecting Graphs of Functions. So what is a piecewise defined function? It's a function that is graphed in separate pieces based on different equations. To graph a piecewise function, we're going to treat each equation separately, but we're going to graph them on the same coordinate graph. So for example, the piecewise function, and again, it's called a piecewise function because there's two separate pieces. So we're going to graph the equation of y equals 3x plus 3, but we're only going to do it for all of the x's that are less than or equal to 0. Then we're going to graph the equation negative x minus 1, but only for the x's that are greater than or equal to 0. So there's a couple different ways I can do this. I can either do it with a table, or I can graph the entire line and then erase it. So let's start with graphing the entire line and then erasing part of it. So for this equation, my slope is 3 and my b-intercept is positive 3. So I'm going to start at positive 3, go up 3 over 1, up 3 over 1, up 3 over 1, and there would be my graph. Oops, I only went 2. But again, they only want this function for all values that are x less than or equal to 0. So I come into the x's, I look at the ones that are less than or equal to 0, and so I would erase, I can't erase part of it, darn it. And I would erase just everything that is greater than or equal to 0, so all of that. Now, I also have to be careful looking for the fact that this is less than or equal to, so making sure this is a solid dot. On the second one, when I start it, x is greater than 0, so it's going to be an open dot. So doing the same thing for the second one, I start at negative 1. I'm going down 1 over 1. And I draw my line like that. Now, I only want to do it for x's that are greater than 0. So here would like x positive 1, x positive 2, x positive 3. So I only want those. So I'm going to erase this half of the line. Also, I have to look for the fact that this needs to be an open circle because I'm only doing numbers that are greater than 0. And I'm not doing greater than or equal to, so I don't fill it in. Okay, the second way you could do it is you could do it with tables. So I could do XY tables for both values, for both equations. And on this one, I want x's that are less than or equal to 0. So I'm going to use 0, negative 1, and negative 2. And these ones I want values greater than 0. But I'm going to include 0, but I'm going to make a mark here that knows that this is an open circle because it's only greater than. So then what I'll do is I'll use my x values here and substitution into my first equation. So it says take negative 4 times 0 minus 2. Negative 4 times 0 minus 2. Negative 4 times negative 1 minus 2. And negative 4 times negative 2 minus 2. Which gives me negative 2, positive 2, positive 6. This one, for the second one, I'm going to be using the second equation. So I'm going to be using the x plus 1. So I'm going to 0 plus 1, 1 plus 1, and 2 plus 1. 1, 2, and 3. This top one, I remember that it's greater than or equal to, so I'm going to use a closed circle. So my first point is 0, negative 2, then negative 1, positive 2, and negative 2, positive 6. It's going to continue in this direction. For the pink line, I know that it's open, and I have 0, 1. Oops, come on. 1, comma 2, and 2, comma 3. And I've graphed both pieces on the same equation graph. So those are the two different ways that you could do each of these problems. The next thing we have to remember is what is the difference between linear, quadratic, absolute value, and square root graphs. And so I put a picture of each of these on here so that we remember what they look like. So for a linear graph, remember it's in the form of y equals mx plus b, and a linear graph always makes a straight line. So it's got the word line in it. A quadratic graph is when you square the x term. And once you do that, it creates this parabola-shaped U-graph. An absolute value graph has an absolute value in the equation. And when you do that, it creates a V-shaped graph. And I remember that it does that because absolute value has a V in it. The last one is if you take the square root of x, it creates like this half a parabola that's kind of laying on its side. So after we're able to identify the graphs, what we're also going to do is move them or translate them according to their equation. So we have some rules here that we had taken in Algebra 1, so it's kind of a review here. Any number that is tacked on or added or subtracted to the end of the equation moves the graph up or down. It's going to move it up if it's plus a number, and it's going to move it down if it's minus a number. And that needs to be at the end of the equation. Any number inside the grouping symbols with x, and so grouping symbols could either be parentheses, absolute values, or if they're underneath the square root together. If there's a number inside with x, it's going to move the graph left if a positive or right if it's a negative. And that kind of seems backwards, but the reasoning is if I had x minus 2 in parentheses, I would have to think about how am I going to get the 2 out of the parenthesis? Well, what I would actually do is add it to get it out of there. So if it's a minus inside the parenthesis with x, it's actually going to move the graph to the right. And if it would be x plus 2 in my symbols, it's actually going to move the graph to the left. Any negative sign outside the grouping symbols is going to reflect the graph. So if I had this negative x squared, instead of being a U shape pointing up, the negative out front is going to put it flipped down. Or if I had negative absolute value of x, instead of being a up V, it's going to be a downwards V. So it's going to reflect it over the x-axis. Any number multiplied on the outside of the grouping symbols widens the graph if a fraction, or stretches the graph if it's a whole number. So if I would do y equals 1/2 x squared, the original one would look like this. And once I put the 1/2 in front of it, it actually is going to widen our graph. We call this a horizontal stretch. If it's a whole number out front, kind of think of it like a slope. So now instead of my slope being up 1 to the right 2, this one is up 2, right 1. So it's actually going to make my graph a little bit narrower. And we call that a vertical stretch. So we're going to be looking for all of these things after we determine what type of graph it is based on its equation. Then we're also going to determine how is it translated from the origin. So on this first one, looking at the equation, I see the x squared value here, and so I know that this is a quadratic. And so I know that the graph of a normal quadratic looks like this. Now this quadratic is different because behind it or tacked on to the end of it, so that's going to follow rule number 1, any number added or subtracted to the end of the equation moves the graph up or down. So because this is a quadratic and the plus 3 is at the end, it's going to take the parabola and move it up 3. And so when it says describe each of the following, so it's a quadratic, and then I would say I can just use an arrow up 3 from the origin. The second one, I just have y equals parenthesis x minus 3 plus 1. There's nothing being squared. There's nothing being square rooted. There's no absolute value. So this is actually just a linear equation. Now this one has two things. Instead of just being y equals mx plus b, and the m in this case would be 1. So there's no change to the slope. There is, however, two shifts. The first one is a number that is added or subtracted inside the grouping symbols. So that follows rule number 2. Any number inside the grouping symbols with x moves the graph left if a positive or right if a negative. So this one is x minus 3. So this is going to be moved to the right 3. It also has a number added to the end, and so it also is going to be moved up 1. So this one, if I go from the origin, I'm going to go right 3 and up 1. My pen is not following very well, but that is basically what it should look like. We don't have to draw the graph. I'm just drawing it for reference. When you go to do your homework, all I'm going to expect to see is what type of graph it is, and then what are its movements. On this next one, I have y equals negative square root of x plus 3. And so this one also has two movements. The first thing here is a negative that is outside of the grouping symbols is going to reflect the graph. So we're going to write reflect. And then I also have this plus 3 at the end, which is going to move my square root function up 3. So the original square root function looks like this. And this one is up 3 and reflected. So it's going to look like that. It's going to be flipped upside down and be up 3. On our last one here, we have f of x equals the absolute value of x minus 3. So I know this is an absolute. Oh, I didn't write this one. This was the square root, but I didn't write it out. But this one's the absolute value. And then minus 3 is inside the grouping symbols. So I know it's going to go left or right. And this one is going to go right 3. So the original of this one would look like this. And the translated version will be right 3. It would look like that.